Okay, the relief has been milled out, and now I'm going to put some more layout dye on there, simply to kind of reverse this. This is almost like a negative now, so that as I take cuts over here, the red here will be pronounced. Now I've installed my 60-degree dovetail cutter, 3/4 diameter, 3/8 shank. Bought that from Enco. Now I actually could use a bigger one than this for this size dovetail. It should be the next size larger. I do not have the next size larger. Because of using this size and the depth that we're going, there's going to be just a little bit of a flat spot right here. But it's going to have to do, because I'll just knock that off with a file and it's going to work just fine. Already we are ready for the first cut. I'm going to concentrate on this end and get it down to a full dovetail. I don't need to worry about dimensions yet until I do the other end. That's when we'll start measuring. Now make sure you get your dovetail cutter good and tight in the collet, because there is a strong tendency for them to want to pull themselves down and spoil your piece. So I've got that good and tight. Now let's take a couple of cuts and watch the red layout dye. Remember, I've already set the depth. We can take some rather heavy roughing cuts to start with, because we're not taking much off, but as we get in farther into the dovetail, lighter cuts will be necessary. Also, I like to take my last pass climb milling, because you get a little bit better finish. Get some Aluma-Cut fluid in there. I'll take it down to almost to a point off camera. Okay, we are down to the right depth, or in the x-axis, that is. Notice that at the top here there's just a little bit of a flat spot, and that's what I described a moment ago. So this side is done already. We're going to move the camera and move the machine and start cutting on the other end, and after I get into a little ways, I'm going to take my first reading using the micrometer and the dowel pins. We're ready to take our first cut on this other end. Be sure and lock the x-axis, because we're feeding in the y-axis, so that there is no movement. And so on. I have taken several cuts, and now we're going to measure. I know I'm not quite there yet, but if you recall, that's what I want, 1.253. So we'll put our dowel pins in there, and I am using the digital readout in conjunction with this now as I take my cuts. I normally don't like to use this for this situation, and I won't when I get down close to dimension, but just for the roughing. We are now at 1.239, so call that 240. We're only about 14 or 15 thousandths away from our final cut, so I will start approaching it a little bit slower, and then I'll get the other gauge. I'm going to use the planer gauge to take my measurements. I've taken several more cuts. I've got the dowel pins in there, and I'm using the planer gauge. Got it in there snug. Now we're at 253.5, fluctuating a little bit. I'm going to check it with the micrometer now, but I think I'm there. This, I believe, will be my final pass. I took off several more thousandths. I've got my X-axis locked. Now when I feed back, I'm not increasing the feed at all, but now I'm climb milling, and I like that for a final cut. Make sure the machine is off when you measure. Get all the chips out of there. And we can put our dowel pins in. Got to get that cutter out of the way. Are my hands in the way? I like this planer gauge for this operation. And let's see what we got here. .250. I'm going to use the micrometer now. Got a 2-inch stirret there. I like my stirret tools. Did I ever say that? Alright. 1.2, let's see, 252. I'm going to call it quits and take it out in the garage and see if it goes on. I want just a little bit of slop. I don't want it so tight I have to drive it on, because remember, we're going to be able to tighten it with our tightening screw to lock it in place. I'm out in the garage again at my South Bend lathe, and what a difference from yesterday. It's 60 degrees here in Illinois on February 29th. This is leap day or leap year or something like that, the year 2012, and there must be some kind of mistake, because it's 60 degrees here. I'm quite comfortable in an unheated garage, and I even made a batch of castings in my fair weather foundry today. Anyway, back to the subject at hand. Now, do not take this out of the milling machine until you're sure you are to size, because you'll never get it back in there for just a minor cut. I did have to spend a little time filing right here, as we talked about before, to get those ridges off, because I needed a larger cutter. But watch this now. If I can zoom in a little bit. I do have pretty nice fit. Matter of fact, a very nice fit. Now the next thing I'm going to do is, right here there is a threaded hole at the end of my screwdriver, 1/4 20, and I had to clean that out. There was 50 years worth of chips in there, so I ran a tap in there. Now I have in the hole a transfer punch. Do you recall me talking about transfer punches in one of my other videos? And can you see just the tip of it sticking out? And I'm going to push the project up against that and tap it. Brass drift, ball peen hammer. And that marks it for a hole that we have to drill. Basement, here we come. I misspoke a few minutes ago out in the garage when I was talking about transferring this hole. I called them center punches or transfer punches. I goofed up again. But in fact I used transfer screws. That's transfer screws that come in this little case and shown in one of my other videos. I will now drill this hole 1/4 inch, which it looks like is going to greatly weaken that, but for what this is, it'll still be plenty strong. But if I had chosen a slightly thicker material, or if it was steel, it would be stronger, but that will be a weak spot. Then we also need to drill and tap a hole on the end. I've already laid that out. And remember, there's going to be a brass pin in there, cut at an angle, and then a set screw. So we will have a 3/16 hole all the way through, and then I'm going to drill it 13/64 partially through and tap it 1/4 20 for that set screw. I will do that now off camera. However, I will show you how I'm going to hold that to drill this hole. I'm at the Walker Turner drill press, and I've got the work set on end in a drill press vise which is laying on its side, and I am prepared to drill my pilot hole, which is going to be 1/8 inch all the way through. Then I will drill it 3/16 all the way through into the dovetail. Then I will drill it 13/64. I haven't decided on the depth yet, and then tap it 1/4-20. I'll use my depth stop when I make that second operation. That will all be done off camera. I am now fixing to tap the hole. 1/4-20. I'm going in there as far as I can with a taper tap, and then I'll go back in with a plug tap, and that's I'm using some fluid on that. It's about 1/2 inch deep for the threaded portion. Then we're going to take this brass rod and we're going to mill a 60 degree angle on the end of it, and we'll do that over on the Bridgeport. We're back at the Bridgeport, and I have that 3/16 brass rod in the vise, and it's setting on one of those thin wavy parallels, and I'm using the same 60 degree cutter here, and all I'm doing is running it back and forth and milling an angle on there. Now this could be done by many other methods. It could even be done on the belt sander, or it could be done by holding the work at an angle in the vise and using a regular end mill. But since this setup was already made, I thought this would be the easiest way to use it, and another way to use a dovetail cutter. As you can see, here's the brass rod with the 60 degree cut on it, and it's going to fit into the hole. In a manner like that, so that the set screw can push against it and lock this onto the dovetail on the South Bend lathe. So I'm going to cut this off on the black mark, and then this 1/4-20 set screw will go in there and push against that. Then we're going to take, and I've drilled the hole right here, and as I told you, it sure did weaken it. Pretty thin there. I can see it wanting to bend there a little bit, but for our purposes and what this is going to do, that's not going to be a problem. And then after I get that done, we got about 5 minutes of work here. I've deburred everything, and then we're ready to go back out on the South Bend lathe and show you how this is used. Back in the garage, and it's about 2.5 or 3 hours since my last little session here in the garage, and the wind is howling in Illinois, and the temperature has dropped 20 degrees since I mentioned it last. Old man winter is returning tonight. Well, the project is done. I softened up the corners a little bit. There's a little brass insert in there. Got a set screw in the end. Cap screw here. And we're going to put it onto the cross slide here, onto the dovetails, using my Bondus brand Allen wrenches. I'm going to put it in that hole a little ways, just for demonstration purposes. Now I'm going to take the other Allen wrench and tighten it. You know, could be any place here. I'm going to tighten it in this position for now, just for the sake of conversation. Now, when a fella embarks on a threading job, he can set this any place he wants it, and it can be set as a stop in the direction coming out, or, watch this cap screw here, as we come in. So we got a double stop. Some people, when they're threading, like to back it way out. Well, you don't want to go too far. And then when you're ready to take your next cut, rather than watching your collar and your zero, you just bring it in till it stops, feed your compound a few degrees, a few thousandths rather. That's loose right now. And it really speeds it up. So it's nothing more than a thread stop. South Bend did make this out of cast iron, but I think they're kind of expensive if you can find one. That concludes this little lesson, gentlemen and ladies. Hope it was enjoyable and useful to you. Tubal-Cain signing out and saying so long for now.